Yeah, I'm gonna put that over here. I'm gonna start. See, this is my object over here, and you know that. So when you have an object over here, you're gonna have two forces acting. You have the gravity force, which is the weight, and then you have the normal force that is acting up. And when the object is not moving up and down, you know that those two forces, they are balanced. Okay, so equilibrium. You learned that. You were in my POE class last school year. You know that you reach a static equilibrium, meaning that you're not going to be moving, when the sum of all the forces in the x-axis, they're equal to 0. And when the sum of all the forces in the y-axis, they are equal to 0, you are not moving right, you are not moving to the left. You are not moving up, you're not moving down. Do you understand that part? Yes, no, maybe?
No, say it again.
Okay, so an object is gonna reach like a static equilibrium, so it's not gonna move at all, up or down, left or right, when the sum of all the forces in the x-axis, they are equal to 0.
Okay.
And when the sum of all the forces, which is the net force, okay, in the y-axis, they are equal to 0. Okay, by the way, when you're looking for all the sum of all the forces in the x-axis, you are looking for the net forces in that axis. You understand that, right?
Yeah.
In the y-axis. And when we were checking the homework, we were analyzing when forces, they were acting up and down, left and right. Yes or no?
Mm-hmm.
Okay. Miss Rama, what is that? This is a triangle. You have a triangle over here. Yes or no?
Yeah.
Hypotenuse over here. And if you have, I'm going to call that theta. Bueno, whatever. Theta. Theta. In Greek, it's called theta. See.
Oh, that
Theta.
symbol?
See, that symbol, see, it's called like that in Greek. If you have an angle in there, this is the adjacent side. Over here, you have the opposite side. Okay, the sine of that angle, okay, sine of the angle is going to be equal to the opposite side over the hypotenuse. Yes or no? Yes, maybe, Miss Ramos.
Give me a second, I'm copying. Yeah.
And the cosine. Oh, that's not the symbol. The cosine of the angle, adjacent side over the hypotenuse. Yes or no?
Yeah.
So if I know that this angle is 45 degrees and I have the hypotenuse, can I find the adjacent side? Yes. Can I find the opposite side? Yes. Because from this equation, opposite side is going to be the hypotenuse multiplied by the sine of the angle. Yes or no?
Yeah.
Miss Ramos, what are you talking about? Sokatoa. So over here, if I want to find the dimension of the adjacent side, it's going to be equal to the cosine of the angle multiplied by the hypotenuse. Miss Ramos, what are you doing? Eh?
If you want to find what?
Adjacent, this side over here. Adjacent. How do you say that?
Yeah.
Okay.
Like that.
Okay.
Well, that's all. Why did you write it out?
Huh?
Isn't whatever, miss. Never mind.
Pero talk to me. Talk to me, I do not understand.
No. That you just wrote the same thing.
What same thing? Over here I have the cosine of the angle, and on here I was isolating the adjacent side.
Yeah, exactly. You were just isolating.
Okay, isolated. No, it's not the same thing.
Well, I thought it was a different. I thought okay.
Okay, so yeah, now you realize that it is related.
Yes.
Okay, now okay. Mirama, what are you putting in there? Okay, this is an object that I have over here. Okay, an object that I have over there. But instead of pushing that to the left or to the right, I'm pushing that with a force at an angle. And the angle that I have over here, 30 degrees. Y me Ramo. What are we gonna do with that? See, like 3 minutes ago, you were saying that we need to analyze the forces in the x and the y-axis, and now we have force at an angle. That's simple, guys. You're gonna do this. When you are doing this, you are finding the components of your force. That force that is applied at an angle can be decomposed on the x vector and let me use another color, your y vector. Ramo, how are you gonna do that? Okay, this is my force over here, and I have that force applied at an angle. Yes or no?
Yeah.
Okay, this one over here is my y component. But that y component, see, is the opposite side. No? According to SOHCAHTOA, sine of 30 degrees is going to be equal to the opposite side over the hypotenuse. Who's the opposite side? F in y. Who is the hypotenuse? F. So if I want to find the component in the y-axis, because I need to analyze if that force is going to break the gravity force, how are you going to isolate that? You multiply the force, that most of the time is a given, times the sine of 30 degrees. See what I did?
Yeah.
And you're going to use that magnitude to create your new free body diagram to see which way your body, your object is gonna move. Okay, now, okay, the component in the x-axis. Okay, how you gonna find that? The component in the x-axis, see, that side of the triangle is the adjacent. So I'm going to use another color. Cosine of 30 degrees is the what? Adjacent side over the hypotenuse. But who is the adjacent side? F and X? Yes or no? Whatever you say, Ms. Ramos. Who's the hypotenuse? If I want to look for my component of my force in the x-axis, the only thing that I have to do is to isolate that. See that? Okay. You want some numbers in here? Okay, I'm going to give you some numbers. Let's say that the mass of this subject is 10 kilograms. And let's say that the magnitude of this force that was applied 30 degrees, like right from north, okay, or right from up, okay.
Or can you give like northeast instead?
Yes. When they're giving you word problems involving force, they're giving you, see, they're gonna tell you that it's a force that was applied 30 degrees north of east. See the difference? No, east of north of east. So you're going to start, see, in the east, and then you're going to move 30 degrees to the north. Okay, so let's say that the force is 20 newtons. 20 newtons. If you want to know, you want to find the components. What do you want to find the components? Because you want to know, okay, by the way, okay, here, bueno, I don't know, maybe you want to know if the object is going to move up. Forget about to the side, because to the side is too easy. What is the only force? Okay, let me make over here my new, this is my new free body diagram. Free body diagram. Now I have a force that is acting on the x-axis. Now I have my gravity working this way. I have the normal up. And in addition to the normal, I have the component in the y-axis. See that? Now, what can you infer from the free body diagram? For sure it's going to move to the right. Y is going to move to the right. Y is going to move to the right. Do you have any other forces acting on the x-axis? They are not paying attention to me. So, no. So, the forces on the x-axis, they are unbalanced. So, for sure, it's going to move to the right. Do you know if this subject is going to move up or down?
No. No.
No, it's not going to move up or down. Why not? Because with the force that you calculate over here, let me see, I don't know. Times, what is that? Sine of 30 degrees. What is the sine of 30 degrees?
Oh, you're right now.
Okay, 0.76. I don't know. Sine of 30 degrees in your calculator.
I got 0.5.
0.5. 0.5. E 0.5, that's 10 newtons. Okay, 10 newtons. And you know that the weight of the object is 10 kilograms multiplied by 9.8 meters per second squared, which equal 98 newtons. This object is going to move up.
No.
At all. Because that force applied at an angle, the component on the y-axis is not going to be able to break the gravity force. See why I'm doing all of this? That for sure it's going to move to the right. Do you understand what I'm doing? Okay.
Yeah.
Okay.
Yeah.
I'm going to continue. Ramos, what are you doing all of this? Let me see if I can find an example. Uy, mi Ramos, what is that? This is an inclined plane, but we have a problem. The normal always is acting opposite to the surface, the contact surface with the object. The normal always up. But what happened with the gravity force?
Always straight down, right?
Ay, mi Ramos. It was going to happen there. Now you have over here gravity force is going to decompose over here. See that? Because the angle is there. So you have a component of gravity in the x and you have a component of the gravity in the y.
Wait, what?
Yep. When you have an incline and you have an object in that position, the angle is between the gravity force and the y-axis. So now you have a component of gravity in the x-axis and a component of gravity on the y-axis in there. This object, okay, let me give you some numbers. Let's say that I'm applying a force over here equal to 20 newtons. If the mass of that object, 10 kilograms, one more time, 10 kilograms. Let me use that. The object is going to move up the incline, down the incline. When I'm talking up and down the incline, I'm talking about the x-axis. Or it's going to move up and down in the y-axis? I don't know. And that's why I have to analyze that. Now, look over here. Adjacent side. What is the adjacent side now? The component in the y-axis. Okay? What is the opposite side now? The component here in the x-axis is in the opposite side. Do you understand what I'm saying?
Yeah.
Yeah.
Okay, so let's say that I want to find the component in the x and the y-axis for gravity in this case. Okay, component. I'm going to start. Y-axis, see, is in the adjacent. So cosine of 30 degrees is going to be equal to the adjacent side over the hypotenuse, which is the gravity force. Okay? Okay, but I want the component on the y-axis, which is the adjacent side. So the component of the gravity on the y-axis is going to be equal to my gravity force over here, multiplied by the cosine of 30 degrees. See that? Now, let me use another color. The component of the gravity on the x-axis. This is the angle over here. And this is my component over here. It is on the x-axis. So, it's see, if you have that, the component of the y is related to the cosine, caballero. Eso se cae de la mata. Sine of 30 degrees. This one is the mass multiplied by gravity multiplied by the cosine of 30 degrees. This one over here, the same story, by the sine of 30 degrees. Okay, so calculator, please do this for me. 10 kilograms multiplied by 9.8 meters per second square. What is the cosine? This one is 10 kilograms multiplied by 9.8 meters per second square. Multiplied by the sine was 0.5. Y the cosine 0.77. I don't know. I think it's the same. No, I don't know. No. For 30, no, it's not for 30. What is the cosine of 30 degrees?
Give me a second.
Okay.
I was writing it down. Alright.
0.866.
Okay, 87.
Yeah.
Now, Mauricio, multiply 98 times 0.87. You know that when you're multiplying a whole number by a decimal smaller than 1, always you're going to get a small number. See, so the component in the x or the y-axis of any force, in this case we're analyzing the gravity force, but the components in the x and the y-axis of any force is always smaller in magnitude than the original force. Understood? Or you want me to repeat that one more time?
Repeat it one more time,
Okay,
please.
the components of in the x and the y-axis of a force always is gonna be, both of them, they're gonna be smaller than the magnitude of the component is always gonna be smaller than the magnitude of the force that is applied at an angle. No?
No,
Why not?
I didn't understand. You confused me again. Say it again, miss, so I can understand.
The magnitude.
Slowly.
Okay, you're gonna say that. The magnitude of the component force, in the x and the y-axis, the magnitude of the component force. Remember that we're talking about forces that are applied at an angle. In this case, you have the gravity, but on the other case, I was applying the force. So I didn't have an inclined plane. Still, I was applying the force at an angle. the magnitude of the component force always is going to be smaller than the magnitude of the force that is applied at an angle.
Okay.
Do you understand it now?
Yeah.
Because they're going to be, see, it's going to be affected. Gravity is the mass times that, the constant. But if you have another force, which is the mass multiplied by the acceleration, that force is going to be affected by cosine or sine of the angle at which the force was applied. And that number always is going to be a decimal smaller than 1. No, Miss Ramos, you're talking too fast. Okay, but Mauricio, give me this number. 98 multiplied by 0.87.
84.87.
87 Newton. And give me the other one. And this one is the sine. Okay. Is the sine. The sine was 0.5.
Yeah.
So you have 98 divided by 2. That's 46. No. Okay.
49.
49 newtons. Ms. Ramos, what are you going to do with that? With that information, what can we do? You are going to create your new free body diagram. Okay?
Wait, Miss, are we trying to find the normal force?
I was looking for the components because I want to know, listen to me, in this problem, I want to know if applying a force equal to 20 Newton up, I'm going to be able to move this subject.
Oh, okay.
Okay? So, first, I need to find the components of the gravity force. Because now I know that I have over here, in the x-axis, I have my component over here. That is equal to what? 49 newtons. I have a force that is applied in the opposite direction equal to 20 newton. I have the normal over here. That the normal, that is equal to 98 newtons because it's the mass multiplied by the gravity.
Yeah.
And I have over here the component of the gravity in the y-axis, which is equal to
98.
This is a mistake. 98. 90. On the y. It's 84, no? 84.87 newtons. I don't know. Is it not? The normal is gonna be equal to that too because it's not moving up. So I'm moving that. I'm sliding that to the surface. So the normal is gonna be affected by that too. See? The normal is gonna be affected by, because I'm moving that. See, imagine an inclined plane, and you're moving this up. See? That's what I'm trying to do. You are moving this up. Okay, so you're not moving that up. So the normal is gonna be affected by the component that you have in the y-axis. It's gonna be equal to that because it's not moving up or down. Okay? So if I use a force equal to 20 newton, am I gonna be able to move that object up?
No.
At all.
No.
At all. Why not? Because I have to overcome this force that I have over here.
Miss, would you be able to solve one of those? Never mind.
One from ingenuity. You want me to solve one from ingenuity? In ingenuity?
No. That's not what I was gonna ask. I was gonna ask a hypothetical, but it was about to be a stupid question because I answered it myself.
There's no stupid system. You're gonna put the rectangular coordinating system, and when you are representing the gravity force, you need to find where the angle is in there. If the angle is, okay, let me say this slowly because I know what's gonna happen. I know. If the angle is made between the force and the x-axis, the y component is gonna be associated with the sine of the angle, and the x component is gonna be associated with the cosine of the angle. But if the angle, okay, let me see. A ver aquí. Over here, I'm going up. If the angle is made, a ver, between the force and the y-axis, remember here, it was the angle was between the force and the x-axis. If the angle over here is between the force and the y-axis, the x component is going to be associated to the sine, and the y component in there is going to be associated to the cosine of the angle. Did you get that now?
Yes.
Okay, so your first step when you're solving problems like this is just to draw a picture of the problem, just put on top of the object the rectangular coordinating system, and find where in there you have your angle. If you have the angle between, see, the force that is applied at the angle and the x-axis, or if you have the force applied at an angle, if the angle is made between the force applied at the angle or the y-axis, depending. You have to put over there and analyze what are the identity, the trigonometry identity that you have to use. Questions about that? I think
No,
that
leave it up for a second.